Hello everyone. My name is Narendra, and I did my master's in information technology from University of Cumberlands, and in the master of information technology. Today, I am going to illustrate about my paper about the enhancing the test automation with deep learning and techniques of the challenges and future perspective on the how ML and AI and the deep learning is going to be integrated with the our test automation thing. So, is my voice clear now, Deepthi?
Yeah, it's clear.
Yeah, it's
Yeah.
clear. You can go ahead.
Yeah. Thank you, Arul. Okay. Let me introduce my affiliation as a information technology in the Master of Science, right? So I am working at the aviation industry, wherein we are implementing the artificial intelligence as well as the machine learning in test automation area. In this space is like we are delivering the product after doing the all those phases of the continuous integration, continuous development, and everything. So we included artificial intelligence. So I thought to come up with a, research article on this one. So this is the background of my effort, which I am presenting today. So how the artificial intelligence is going to be affect our uh, test automation space is like the rapid evaluation of software development practices is already implemented the artificial intelligence, wherein we now at this point of time why we are do what we are doing is like the test automation also in the deep learning. So the frequent changes which we are doing at this point of time is like how the subset of test data is going to be affected, how the UI automation is going to be affected, and how the API automation is going to be affected with this artificial intelligence and the deep learning of the data sets, as well as the self-healing and predictive analysis, bug prediction, all these things we are going to be learn on this. So uh, coming to the coming to the literature review, as I mentioned in these things, right? So most of the capabilities or the limitations of the AI in the business applications, right? So these are giving the things wherein we can utilize the capabilities of the AI and ML. So most of the references I had mentioned here were in from 2016 and 2018 also. Most of the AI and my papers are also was published in a different publications. So I will be quoting all those things. First, we are going to the how we are going to introduce and incorporate the capabilities into this. So first one is the automated test case generation. So there are most of the AI space tools are utilizing now in this space, wherein techniques of the test case generation. So Accenture has their own tools, and Wipro has been introducing their own tools. So there are very big boys which are Meta and GPT also. Chat GPT is also giving the capability to generate the test cases. So yesterday also had given the POC on that GitLab Duo, wherein we can generate automated test cases, that is the unit test cases as per the code blocks. So how the AI has been included in this test automation is that is the greatest example. So this AI is making the life of a developer as well as the test engineer as a very easy to do their jobs with a very minimal defect leakage into the production, as well as the minimum test case creation manually. So this is the reason what we are learning here is like how to improve the AI with our deep learning techniques. So in the first phase, as I'm mentioning here, just I'm highlighting this one, automated test case generation. For example, recurrent neural network is the RNN, and their variants such as long short-term memory LSTMs. So these all are related to the effective sequence prediction task. So if you are going to predict any of the test cases, how it has to be executed and how it has to be generate the data for a given test case. So this test case generation is dependent on these RNNs and the LSTMs. So that's the basic of the deep learning. So it will go inside of the code blocks as well as in the test case scenarios which was written by the business analysts and also domain experts or the SMEs, right? So those things will be analyzed and then it will come up with a test case generation based on that data set. So the practical example can be seen from the LSTM model, which was trained. So there, the word trained used here because it is not like one of the project has been completed and the model has been completely understood our domain. No. So what we have to do, that is a myth. Everyone was in an assumption wherein the machine learning language, when we are adapting and plugging, that will be learning everything. No, we have to train the model in such a way by giving the multiple scenarios of the data into that one. Okay, so that's the reason we have to say it as a trained. So multiple multiple data sets has to be given, multiple use cases, multiple user stories, everything has to be given to the LSTM model. Then it will be learning for learning the scenarios to understand and to do the deep learning of the scenarios on that. Okay. So I had given you the diagram wherein we can understand the how the test case generation will happen. So this is the input which I am talking about, the user stories, the data, which are written by the business analyst or the SMEs, and then now we will be our model will learn from this is the LSTM model which I was talking about in this one, right? The network architecture of the machine learning model. So to do the predictive analysis on that. So LSTM model will learn from the input which has been given. So these inputs may vary based on that inputs. The model will get trained and generate the test cases in such a way. In future, we are not going to any defect leakage to the production will not happen based on this test generation. So that is the beautiful of the functionality given by the ML. Based on the training, the accuracy will increase 99% and 90. Sometimes it is 100% also, no defects in the production. Also, we can make sure by giving the different sets of the data. So that is that one. So that is the model, and we have to give the training. So these are the test cases, and output of the test cases will be considered as a considered as the test cases which we can upload into the Jira or whatever the test automation tools which are using. That is the thing. So yeah, Deepthi, can I continue, or is there any questions from anyone?
You can continue. After your presentation is over, let me know like with any questions are there.
Okay, thank you so much.
Yeah.
Let me go on with it. Yeah. So so the generated test cases are in such a way like whatever the model has been created, the created test cases. Just this is the illustrative diagram for each of the each of the product, each of the module, each of the sections. The test cases will be get generated, and then those test cases will be executed on the product on the different levels of the application. So now what we are going to achieve by giving the different sets of the data to the model, wherein a LSTM model will learn everything, and then what is the use of that one? So that is the biggest use, is like bug prediction and the classification. So what it will do when few of the bugs has been identified in the first execution of the thing, then immediately our model will learn the things, which part of the software or which part of the module or product, which part of the user story is giving or throwing more errors, and which one has been developed, that one. So that is the prediction, that is the deep learning of the things which will be done by the model, and it will gives us the user report saying like this is the piece is giving the more issues on that. So that is the bug prediction. So bugs are something like that which will be uncovered during the testing of the application. So those are the bug prediction, and the classification is something like that, as I said, right? Which of the user stories or which of the developers code is giving the more bugs into the production. So that is the classification. So bug prediction and the classification can be done through the model training. So more data we are giving as an input to the model, more prediction, more deep learning, and more prediction into the bugs. So that's the beauty of this model training. So the bug prediction and classification will save the most of the time of the organization, and cost also will go down mostly into the 80% down of the things which we implemented in the most of the MLs, right? So it is having the very huge amount to the organization. So that's the reason the AI capabilities and then machine learning capabilities and also the deep learning capabilities has to be improved for every organization, so that so that if we are seeing any issues in the any of the applications, right, that will be go down. I cannot say it is go down for 100% of the sure, but it will go down at least 90%, so that only 10% of the manual work has to be done by the test engineers to make sure everything is working as expected after deploying or before deploying into the production. So I had quoted one of the case studies wherein CNN model trained on a data set of the code changes in a historical bug report. So bug reports. So the bug report in the sense whenever a bug has been identified or uncovered after the deployment of the code into the production, then each of the bug has to be undergo for a RCA, and then root cause analysis, and then we'll be preparing a report. So that is called it as the bug report. So these bug reports are very important to any of the products or the organization to do a root cause analysis or the RCA. So those bug reports can be given into the ML machine learning to get to know the deep learning why the bug has been released to the production. So those type of data is very important to the ML, because so that that can be predictive in future how to stop these bugs till be reported or bug will be flowed released into the production environment. So that's the very important feature of the ML. So which I am showing here, the picture is like the ML model, the CNN here mentioned, the CNN model trained on the data set. So here what I'm saying, the data set of code changes is something like that, whichever the code has been merged and we created the merge request or the peer request, then that will pull request will be measured into the master. So that is the data set of code changes we are talking about here. So when we are giving that one, then all those critical issues which are being addressed in the bug report can be analyzed, and it will get predict for the future analysis. So this is the decision wherein by looking at the bug trees and analysis and everything, right, it will be giving the decision tree wherein where the bugs has been so accurate, how much percentage of accurate is it is given by the score. So we can mention the different decision trees are also there, including SVM, SSND, and different types of the decision trees will be populated based on the given data set on that. So different types of testing using the predictive analysis reports. So as I said in the beginning of our discussion, right? So API automation test cases are there, or manual thing also there. UI automation test cases are there. So DB analysis. So if we are talking about the visual testing with the neural networks, so what happens, right? It will decrease GUI graphical interfaces, right? When we are testing this one, it will decrease the manual uh, effort by predicting the which portion of the application is giving that effect, which portion of the application is not giving the bugs, that can be predicted. And then whatever the model which we are using here, whatever we are using is the CNNs, right? So in the same visual testing, we can automate those scenarios using any of the automation tools available in the industry. So the example which we are showcasing here is the multiple convolution layers are there to decrease the bug reproduction into the production. So that's the reason we are creating here is the complex layer, so that the first one which we are showing is the simple single layer wherein we have a simple single layer of that one, and we are creating the test cases and execution is happening and the model is learning here. But this is the another thing wherein we are building up a complex environment wherein it is bug reports, data, and then predictive analysis and reproduction of the defects, and everything will be there in this one. So by doing these things, so what happens is like the what is the expected area of the defects is getting reproduced, and what are the preconditions we have to follow in order to stop these defects will be flown into the production, and then what are the test cases has to be generated and the data sets, everything will be sorted out, and then the ML will produce their detailed report of the automating the visual test cases and everything. That will be most useful document for the organization or the product. As I said, there is another concept of this one, right? Self-healing. While we are talking about the automation, there is a self-healing of the test script. Self-healing is nothing but when a test case has been automated and then test case is failing because of the reasons of the development code changes, then our AI will go and verify whether the locator or XPath has been changed or something like that, and then self-heals. Self-healing is the word wherein automation test case will heal, heal in a fix or something like that by themselves. So there is no requirement of the automation as data requirement or the intervention in that one. So AI itself will um, fix the test case no, to get the results out and make it pass into the and give the absolute record on that one. So that is the beauty of self-healing by the AI tools. Now we have GenEQ, AxleEQ, most of the AI automation tools are available to do the deep learning of the DOM and then fix the automation test cases to enable the self-healing of the test scripts. So this is the beauty of this one. So regression testing will be very easy for all those organizations with the minimum effort. So that is the UI testing on that. So we learned how to create the data, how to generate the test cases, how to execute those test cases using the automation. Now we are coming into the performance. So performance is something like that, wherein application behavior, application performance are the load balancer, how many users are being logged into the application, and then how the load balancing is happening for that particular application can be finding can be done using the performance testing tools or optimization tools, wherein load runner or Visual Studio, load balancing tools, or anything we can use to get to know that one. In that also, what we are doing is like we will be giving the threshold, which will be finding by the deep learning of the models. Will the models will give us the exact data where the application is going to be break even, and what is the threshold limit for the application, what is the load balancing the time for that application. So performance engineers can be doing the behavior of the application by taking the data generated by our tool using the deep learning technology and the other LLM models trained. So by incorporating the deep learning performance testing, organization can achieve more accurate and effective testing, ensuring that the application is performing as expected. So actually, we already discussed about the data quality and the quantity also, wherein that it is generating the data models, and the unit testing, performance testing, everything will be done through that. So yeah. Yeah, Dipti, do I have a few more minutes to continue?
Yeah, you have. You can continue your presentation, Narendra.
Okay, thank you so much. Yeah,
Yeah.
I'm time taking. That's it. Yeah, thank you. So, what are the integration with existing tools? What we can do, right? Integrating of the existing tools like automation tools, wherein Microsoft Visual Studio tools are there, and then other Jira automation tools are also available in the industry. So, deep learning techniques can be integrated seamlessly with the existing automation tools also, so that there is no change for the end user, saying like we can integrate with the latest technologies, including the AI capabilities or ML capabilities to do the deep learning on that. So training and deploying of the models can be demanding significantly on the computational resources, utilizing the existing resources and the cloud-based solution. So this is the beauty of the AI capabilities, wherein we can integrate with the cloud capabilities also, wherein AWS, Amazon's providing the AWS and S2 things also, and also in the Azure also, Microsoft providing the Azure, we can integrate with the cloud solutions also. So why we are using the cloud in most of the organizations? The simple thing is the continuous integration and the continuous deployment. So we can do the code deployment continuously, and then we can also integrate with the latest changes into the production. So that is the cloud capability we can integrate with our AI. So there are the case studies also I incorporated in this one, wherein e-commerce platform face the significant challenges in maintaining the accuracy and the reliability. So what happens, right? They will be collecting most of the data from the different portions of the application, and then they will be doing a training of the ML. Then it will be generating the test cases, and they will be doing the automation, performance, UI testing, API, and everything, so that the defect leakage will be go down, and the increasing of the performance, and the organization will be spending less money on the resources to maintain the application. That is the one of the case studies we did on that. And the second one is on the financial services company. Same thing, and the deep learning models will do the existing test automation framework, and to enhance the prediction. So if the bugs are being predicted very early in the stage of the software development, that is very cost effective for the organization and also to the team of that production releases also, rather than deploying most of the code into the several times into the production. They can do one time production deployment, also the testing on that. So this is the mobile application development. The same thing happens, right? We already discussed about the CNN's visual testing of the application across the different devices and the screen resolution. So this is the another beauty of the AI model, wherein the same application will be deployed onto the with Windows platform, or otherwise on the Linux platform, and somebody will be using onto the laptops, or on the full size, or on the mobile devices also, right? iPads and mobile devices. That testing will be happening to the application development using the CNNs performs UI testing. So what are the current scenario is like, we are using the existing capabilities into the existing, or integrating with seamlessly with the existing tools. So and the cloud also it is part. But what the future perspectives? What are these tools will be doing in future? So enhancing the collaboration between the AI and the human testers. What happens when the AI is testers has been written some code, and then AI will be collaborating with those testers to update and refactor their code in order to get the future prediction of the defects, as also integrating with the AI capabilities and predictive analysis capabilities into their automation. So that workflow has been will be coming into the future, so that this is good for the testing team, saying like they are not going to they are not going to lose any of their work, but they can be doing very effective automation in this. So this is the illustrative diagram, wherein how the automation testing is going to be happen, and then how the deep learning model is effectively utilizing the capabilities of the predictive analysis, wherein code has been code commit and the automation testing will be done. But what happens, right? The deep learning model will analyze those automation testing, and then anything has to be updated, then they will be doing, and then the same thing, continuous integration, automation testing, model testing, deploy. So the cycle will go on, wherein deep learning capabilities will update the or refactor the code. Again, it will go into the same cycle of CI/CD and the code commit. So automation testing, model testing, and then again the pipeline and the continuation monitoring. The cycle will go on. This will be the future prediction for this deep learning prediction on that. So advanced detection. Now, what is the anomaly detection techniques is something like that, which I was saying. So what's going into the future? How the defects are flowing into the production, and what will be the what will be the most of the defects are happening in that. So the our LLMs, large language models or deep learning or AI models will be predict the defects onto the application, and that will give us the measures to what are the measures has to be taken in that. So in the broader industry adoption, when we are saying AI will be changing everything, it's not everything. It is not. It is going to be changed, but it will go and update the existing technology, and then it will suggest the code refactor for the automation and gives the capability of the learning of the models, right? That will be a used advantage for the existing team. It's not like that it is going to be take away everything, but it will be giving the refactored or updated and AI capability enabled code to the users. So that way we can save a lot of money to the organizations, and also it will be useful for the resources also. So I quoted most of the references from here, wherein they mentioned in their articles also the same thing, wherein the AI is going to be update the things on that. So this is about myself. I had given in the evaluation. Yep, that's it from my end. Deepthi, thanks for this opportunity.